Okay, so we're going to talk about arc length. This is supposed to be radius. We'll start with arc length. Arc length is the distance. We already know it's the distance between 2 points, between the endpoints of an arc. And in the last unit, we calculated arc length using degrees. If we know the degree of that angle measure, because we know since this is a central angle, the degrees of this arc are equal to the degrees of this central angle. But in this unit, we're going to talk about a different way to measure angles, and they're called radians. So we're going to start with a formula. The first part of the formula is that S. S is arc length. S stands for arc length. So for this unit, S stands for arc length. And I'm going to try really hard to make these S's look like S's and not 5s. The other thing we see here is the radius. Radius. And we see the angle measure, central angle. But this is called theta, which is a Greek letter, theta. Mathematicians love using those Greek letters. And theta stands for arc measure in radians. Arc measure in radians. Radians are just another way to measure angles, and just like we use feet or meters and kilometers and yards and all these different ways to measure distance, we've got 2 different ways to measure angles. One is using degrees and one is using radians. So what is a radian? What is a radian measure? So the measure of an angle in a circle, and it's just the ratio of the length of the arc to the radius. A ratio, remember a ratio is a fraction. So in other words, it's the ratio of arc to radius. The ratio of the length of the arc to the radius. Okay, so in your box, we're gonna say radius is R, arc length is S, and we're also gonna use measure, arc measure is gonna be theta. We just talked about that. Okay, so in general, theta, the measure of your angle, your central angle, is the ratio of the arc length to the radius. Arc length divided by radius. So if I know 2 out of 3 of those things, I can solve for the third one. Okay, so the first example, a circle has a radius of 4 units, so radius 4 units. Find the radian measure. So the radian measure again is theta. It intercepts an arc with has a length of 10.8 units. So this is my central angle. Here are my endpoints. So here's the arc we're talking about. So this is my S, this is my R, and that's what we're solving for. So theta equals S over R, so it would be 10.8 over 4. And if you put that in your calculator, you should get 2.7 units. Again, if I'm going too fast, just stop the video, go back, look at it again. I'm going to keep moving on. So a circle has a radius of 3.8 units. Find the length. So a radius of 3.8 units. Find the length, and at this point you should stop the video and try this one on your own if you didn't guess that already. So you need to find the length of an arc. So I'm looking for S instead of theta here. Intercepted by a central angle, so that's theta, measuring 2.1 radians. So in other words, R is 3.8, theta is 2.1, and S is what we're solving for. So I've got 2.1 equals S over 3.8. Well, how do I get S by itself? Multiply both sides by 3.8, and S equals 7.98, or approximately 8 units. Forgot my units. Okay, so that's how you solve for an arc length, radius, or measure in a circle. Remember that formula. So here's the definition of a radian. When the intercepted arc is equal to the radius, the central angle measures 1 radian. So if this and this are equal, the angle measures 1 radian. Theta would equal 1. So this is 1 radian right here. The angle measures 1 radian. Okay, so let's think about the formula for converting between angles and degrees, because that's the next thing we want to do. In fact, we know the distance around the circle, or the measure, we want the measure around the circle is 360. The distance around the circle is the circumference, and circumference is 2 pi r. What is the ratio of arc length? So if I was using the whole circle would have a length of 2 pi r to the radius of an entire circle. Divide that by r. So arc length to radius, well, that's just 2 pi. So in other words, the measure is 360 degrees. It's also 2 pi radians. So 360 degrees equals 2 pi radians. So 360 degrees equals 2 pi radians. So if I want 180 degrees, half the circle, how many radians would that be? Half of 2 pi, which would just be pi. So if I want to solve for either radians or degrees, let's say I got radians, set up a proportion, over pi is going to equal to degrees over 180. So in general, I'll know either this, radians, or degrees, and I'll just use cross multiplication to solve for the other one. Okay, so let's try one. Convert 40 degrees to radians. Okay, so remember I have radians over pi is degrees over 180. Okay, so I know this, so that's going to be my x. So x over pi is equal to 40 over 180. Well, let's see. 40 times pi, cross multiply, 40 pi equals 180 times x, or 180x. Divide both sides by 180. And it's going to be 40 pi over 180. I'm going to leave it in terms of pi. I just want to reduce my fraction. The graphing calculator can do that for you. If you go to do 40 divided by 180, and instead of pressing enter, press math, fraction, and enter, and it'll do that for you, 2 over 9. So it's going to be 2 pi over 9. Okay, and then you're going to convert 3 pi over 4 radians to degrees. So now I know radians, but not degrees. So 3 pi over 4 divided by pi is going to be x over 180. Now, looking at this, I can see right away that I don't need this pi, because that pi cancels out that pi. So now I've got 3/4, 3 over 4 times 180, and the pi went away, so that's like 1, equals 1x or x. So if I can figure out what this equals, I'm done. So 3/4 of 180. Let's see. 3 times 180 divided by 4. It's 135. Okay, so the triads are right here, so stop the video. Use what I just showed you to do these two triads. Okay, so let's go over those answers. Convert 80 degrees to radians. So now I don't know radians. I do know degrees. So that's going to be 80 over 180. Okay, so I had 180x equals 80 pi, and I'm going to divide by 180. And just, so now I've got x equals this thing, but I want to reduce that. So 80 divided by 180. Don't press enter. Math, number 1, and then enter. So it'd be 4/9. So I'll just put the pi back on top, so it'll be 4 pi over 9. And this one I know radians, and I'm getting degrees, so 7 pi over 6 over pi is going to be x over 180. So the pi's will cancel out, and x is going to be 7/6 of 180, or 7 times 180 divided by 6. So 7 times 180 divided by 6. And that's 210. So x equals 210. Okay, we're almost finished. Now that you can convert, we're going to go back to that original formula we used, and we're going to solve a couple problems. So we've got a circle with a diameter of 20 feet, meaning the radius is half of that, or 10 feet. Find the length of an arc. So we need to find the length of an arc with a central angle, so theta is 36. So remember, the formula theta equals s over r requires us to have our angle in radians. So I can't use this 36 for my theta. So that's actually not theta. How do I do that? Well, I just use that formula we just used. So we've got basically 2 new formulas, and then you're going to get 2 more in the next video. So 2 new formulas, this one and the conversion formula, the degrees and radians formula. Okay, so let's convert, let's convert this to radians. So 36, I don't know radians. So x over 180. Turn off the video and try it yourself, and then come back. Okay, so we've got x over 180 is equal to 36, oops, not x over 180. X over pi is 36 over 180. So I've got 36 pi equals 180x. If you haven't figured out yet, it's the answer is just going to be this reduced with a pi on top. So 36 over 180 reduces to reduces to 1/5. So this will just be pi over 5. So that's not the end, that just gives us our theta. So now I know theta is pi over 5, or 1 pi over 5. R is 10, and I don't know s. So I'm going to do 1 pi over 5 equals s over 10. Well, this looks like I could cross multiply, so let's multiply 1 pi times 10, or 10 pi, equals 5s. Be careful there. Divide by 5. S is going to be 10 pi divided by 5, which is approximately 6.2. It's going to be 2 pi, which is approximately 6.28 feet. Okay,